All right. Welcome everyone to this month's Fireside Chat. We'll be getting started right at 1 o'clock, but I always appreciate people joining early to make sure everything's working on that. All right. Great to see some familiar faces and some new people that I think I don't know. Hi, Kevin. Seeing you here, and Paul. Oh,
Hello.
we've got a few automotive people here showing up for today's chat. I see.
Hi, folks.
Hey. Yeah, so we'll be getting started with the Fireside Chat right at 1 o'clock. So in just a minute, but I appreciate people joining early to settle in. All right, so it's 1 o'clock. We'll get started. Welcome everyone to today's Fireside Chat as part of the Save on Energy Management Community Initiative. And this community initiative is all about supporting the development of a community of practice among Ontario's energy managers. And this includes access to a monthly discussion group, online forum through the Energy Management Learning Platform, and other initiatives. The goal of these fireside chats is to provide an opportunity for members of the community, yourselves, to share some of the great work that's being done, in this case, our guest Alan at Toyota, and allow others to ask questions and have a conversation about it. So we do want this to be interactive. So if you have a question, don't save it until the end. Please raise your hand, type into the chat or the Q&A box. We'll be taking those questions as we go through. So I'm just going to be asking Alan some questions, but if any point you want to jump in, raise your hand or type into the chat or the Q&A, and we'll be keeping an eye on that. So today, I'm excited to have Alan Sutton from Toyota Motor Manufacturing Canada with us to talk about a project that involved installing a variable frequency drive and controls optimization on a paint line. Project that I believe is already cutting electricity, natural gas, GHG emissions, and showcasing the value of robust planning and continuous improvement. So thank you very much for joining us, Alan.
All right, thanks for the introduction, Jay. So I'll take 2 seconds and just talk about Alan Sutton for a second. I have a 30-plus year career. My first 10 years was in research and development, where I learned how to make things different every day. And then I made a career change into operations management. I've been a plant manager at a number of tier 1 organizations where I strove to learn how to make things the same every day. A little bit change in direction. And then I made one more career change. And that was to get into the energy industry. I knew nothing about it when I first came here. My first job was to take an existing company and split it up into a software company and an energy auditing company. And at the end of that task, I was asked to be the manager of the energy auditing company. So that's my introduction to the energy industry. Haven't looked back since. I guess in a general introduction to Toyota, we have 2 plants in Ontario, one in Cambridge, Ontario, one in Woodstock, Ontario. Cambridge is the larger of the 2 and is really an amalgamation of 2 plants. We're about 3.6 million square feet on that property. And in Woodstock, we're about 2.6 million square feet. Let's see, make it simple. Woodstock makes RAV4s, and that's the only vehicle that they produce, both hybrid and gasoline. Soon, effective in October of this year, we will only be making hybrids in Woodstock. Cambridge, however, has some interesting, unique features to it. It's the only plant in the Toyota world in North America that has a combined heat and power plant. We are producing 3 vehicles. The 2 of them are Lexus. We are one of 2 plants in the Toyota family that produce Lexus outside of Japan. So we have a unique distinction that way. And we have one more unique distinction in that one of our lines, the North plant, produces both RAV4 and the NX, Lexus NX 350. And it's the only line in North America that produces the same two different vehicles on the same line.
Great.
So that's an overall look at it. In Cambridge, we're about 127 million kilowatt hours a year consumption. Demand is around 32 in the summer and around 28 in the winter. We are summer peaking primarily because we have an executive decision that our plant will be air conditioned. So we have a tremendous chiller load in the cooling season. The Woodstock plant is around about 90 million kilowatt hours a year, somewhere between 14 and 16 kilowatts in terms of load.
All right. So for this project that we're talking about today that involves the paint line, before we get into that, you mind, like, what plant was that at? And for those of us on the call who aren't familiar with the automotive manufacturing as much, what are the common, like, energy using systems or processes within that facility at, like, a high level?
All right, so both plants are basically laid out the same. Steel comes in one end of the building. It goes through stamping process. It then gets transported into a welding operation where we do spot and MIG welding. From there, it goes into the paint shop to have paint applied to it. And from there, we go into the assembly department where it's a nightmare bringing all those different pieces together, and they do it every day. It's amazing. So that's kind of a general overview. The paint lines are, there's two of them in north. There's two, one in south and two in west. And the lines in west and north are both producing the RAV4, which is the home of this project. It is, in theory, two identical lines. In practice, they have unique features. They certainly don't have the same energy profile. So it's been kind of interesting seeing how we have tried to commonize those efforts. The paint process is basically a three-phase primer, color, and clear coat. So the vehicle goes through a number of washes, a number of ovens, and those ovens are where this project is targeted. We have to take outside air and take it up to 600 degrees just to cure the paint systems that we're using. So this project got founded really fundamentally from a change in direction, strategic planning, and our energy management plan. In 2017 through, I'd say, 2021, our focus was on electricity reduction and cost savings. In 2022-ish, our focus became carbon neutrality. And what that did for us is it turned our attention away from electrical savings and cost savings to emissions reductions. And of course, most of the people on this line are knowledgeable enough to know that natural gas is the key utility to address when we're looking at emissions reduction.
Right. So on the paint line, the main energy is like heating it up for the ovens for the curing, but then there's other, like the fans, and there's motors involved and other things like that. So yes. In this project, looking at the VFDs and controls, what was the main kind of savings mechanism that you were looking for? Like, how was that going to reduce energy consumption?
So let's take a step back first, Jay. So the change in direction made us look at natural gas consuming equipment, which means in our case in the oven, heating outside air to process temperatures. And of course, that air has to be moved. So we have motors anywhere from 10 to 300 horsepower on that line. Given the fact that we were changing our focus to natural gas, we decided to do an additional energy hunt. So we had a Saturday afternoon set aside with a team of about 12 people in pairs. And we went through that line looking at all the burners, all the gas lines, all the motors that are moving, the fans that are driving the air around. And we identified a number of opportunities for improvement. And one of them was a legacy issue. So on this line, we had 43 motors. Several of them had VFDs. Several of them did not. As part of the energy audit, we dove a little bit deeper into data collection and the controls, looking at time of use and issues like that. And what we found is the VFDs that were installed were never connected to the control system. I have no explanation of why that happened.
Yeah, it's like, how do you end up with installed VFDs that are not actually doing what they're installed to do?
Yeah, and I have honestly, I have no explanation of how that happened. I speculate that a project engineer changed careers midway through a project, and the project was never picked up by someone else. But that's pure speculation. So it's really the energy hunt that led us to focus on the motors and the VFDs, because we have a KPI, a key performance indicator called non-production energy. And anyone who's known me for any length of time has heard me talk about non-production energy probably for the last 3-4 years. But those are the two driving factors. It was the carbon neutrality, change in direction, and a desire to reduce the amount of energy we're consuming between shifts when we're not actually making vehicles. And that's what led to the VFD investigation. What we found, 43 motors. If we can reduce our motor speed by 50%, it's going to translate to 2.3 million kilowatt hours a year in savings. So it's not a small project. We are, as we speak on this Fireside Chat, about 95% complete on our month-to-month monitoring and reporting systems. I'm already showing the impacts of the VFDs that are in place. So I expect full implementation by the end of July. That's our shutdown period. We have 3 motors that we don't want to touch until we're in shutdown mode.
Okay. Why is that? Like, why is it being phased in that way?
So it's been phased in primarily lack of resources and the risk aversion of the manager of the paint department wouldn't approve the equipment installation and disconnect and reconnect during a normal production week. And it was believed there was insufficient time to do it on a weekend.
Okay. Right. So some of it, like you said, the VFDs were already there. So it sounds like some stuff was already installed and connected. Yep. So are you looking at those opportunities first before installing additional pieces?
Yeah. So that the only thing that we needed was the infrastructure in place to connect it to the internet through the PLC system to our data tracking system. So we're using a VT SCADA system to collect our data. Mm-hmm. And from there, that's where we do our reporting out to both the shops and the executives.
Okay. And we have a question from Juan in the chat about how did you determine that the VFDs weren't working? So you mentioned you went on that walkthrough and saw a potential opportunity, but like, how did you know that they weren't actually controlling the speed?
So and again, I'm going to be fully transparent. When we first did the audit was visual in its nature. So we saw the VFDs, we said, check, yep, we got it, move on. But when we went into the second phase of the energy audit, where we started looking at timing and comparing control setting changes to outcomes, we found that we could change the settings and it had zero impact on the outcome. And that's how we discovered it. It was strictly a case of let the data talk to you, and it did, and not kindly.
Right. So you sort of made control changes that you expected to ramp down at certain times, but the data didn't show that was happening at all.
Yeah. So what we had learned on a previous energy audit that wasn't focused on airflows, we were able to show when we did lighting upgrade, for example, where we could turn the lights off in sections of the shop and show it real time with real data to the people that were conducting the energy hunt. So they saw the impact of their decision or their suggestion immediately. So that philosophy after we did the visual observation, seemed to be a natural progression for the energy hunt on these motors.
Okay. And then what did you see as the main opportunity? Because you mentioned that the paint line manager was nervous about impacts to operations. So are you looking to ramp up and ramp down during like production runs or production
Yeah.
lines, or what is the opportunity here when it comes to these controls?
Yeah, so let me talk a little bit about non-production energy. I'm sorry, I have to. Toyota operates on a two-shift operation, so we have, depending on the duration of the shift, somewhere between 2 and 4 hours between day shift and afternoon shift. And during that time is when we do our PMs, cleanup, those types of activities. The longer break for us is between afternoon shift and day shift the following day, where we can get somewhere between 4 to 6 hours. So again, it depends on the duration of shift. We run anywhere between an 8 and 10 hour shifts. So as demand allows, and we shorten our shifts as much as we can because we like to keep a two-shift operation. So in those periods of time when we're not making vehicles, we have an internal target of during the week, our consumption should be 45% of the consumption we're at, baseline consumption when we're making vehicles. And on the weekend, we have a target of being 23% of that production baseline. So the essence of this project is really controls. It's all about reducing fan speed during periods of time when we are not producing vehicles. There are other components to the project that are required. So if you can imagine a rectangle with two open ends, if you suddenly stop introducing heat into that rectangle, the heat's going to escape out the ends. So we have, as part of this project, designed an interlocking door. So when the VFD setting changes from production status to between shift status, those doors close up and the oven is basically a closed box at that point.
Okay. We have a question in the chat of, if were there submeters on here in terms of like electricity or gas or like natural gas or other things on there that helped with that? And related to that question, I'm curious, like how did you end up estimating the potential savings of starting to use these VFDs and making these control changes?
Yeah, that's a lot of questions all in one, Jay. So let's start with metering. So we do have shop level meters, and we do have meters on our PDPs and MCCs. So we do have the ability to track some electrical consumption down to regions of the shop. We do not have the granularity to do the electrical measurement on a per equipment basis. So having said that, one of our plans obviously is to close those gaps and increase granularity over time. But at the time of this project, we strictly had a main meter going into the plant and 17 meters, sub-meters at various points throughout the line. So we did do our baseline analysis based on meter data. We've been collecting data since before I got here. So we have a very good systematic way of doing our baseline measurements. And that is what I'm using. That same metering system is what I'm using to look at the post-performance and MNV for the project. Now, natural gas is what drove this project. It's also where we have the least amount of metering. When this project started in December, we only had one natural gas meter going into the paint shop. Since then, we have installed, calibrated, and verified the installation of 21 natural gas meters throughout the line. So I don't have a good natural gas baseline at each of that sub-metering level, but I do have a good baseline at the aggregate level.
Okay. And how did you go about estimating what the savings from this project could be?
So for me, I want to say it was a simple task because we had such a great team that was able to do baseline analysis for us. We strictly took that baseline, multiplied it by utility rate. That was our base cost. We are estimating a 50% reduction in consumption, and that was our estimate for savings. That's how we got the project approved.
Okay. And that 50% reduction, is that just from like that your assumptions before of if we can ramp these motors
Yeah,
down for this much
yeah.
a week or something?
Our original project estimate was less than 50%. It was only 27%. Don't ask me about the number. It's a paint shop specific number. But when we added to the scope of the project the ability to interlock the closing doors at the ends of the ovens, then we had a really high confidence level that the 50% savings could be achieved.
Okay. We have a couple more questions about the metering side of things. One of what type of EMIS do you have? And then another one from Paul of how did you verify the gas submeters? And Paul, is that sort of like on like calibrating them or ensuring that they're accurate?
Well, Alan said that he installed, calibrated, and then verified. So, I mean, I've done calibration, but I've always carried the verification.
Yeah, so we had a gas fitter that was the individual responsible for installing the meters, and he was the one that performed the calibration for us.
Okay, but was there
exactly how he did it, Paul? I wasn't there. I don't know.
Was there a verification as well, or just the calibration?
So the certificate that I have is calibration and verification. So it was a third-party contractor that provided that service.
Okay.
And I'm not the project leader for this effort, Paul. So if you need some contact info, reach out to me after the call.
Okay.
And then, so you have the savings estimate, you see this opportunity there. It's pretty good. It's aligned with your goals. Were there any challenges in getting support or buy-in to move forward with it?
So I'm going to say yes.
There always is, right?
No, I think it's a delay tactic. So without getting into too many politics, when Toyota went through the COVID years, we supported our plants 100%. We did not experience any shutdowns or slowdowns. We did have stoppages in production, but during that time frame, we supported our team members and everyone was paid throughout the whole experience. Cost us a lot of money. What ended up happening is our capital budgets shrank in the following years. We were just starting to see those capital budgets open up, and then our friends south of the border started playing around with tariffs. So yeah, we've had some very long discussions about capital expenditures. This particular project, Toyota has a very strong culture in project approval on a single piece of paper. It's an 11 by 17 sheet of paper called a ringy. And the ringy is basically a storyboard that says, what's your problem? What did you do to look at alternatives? Which alternative do you suggest and why? How much is it going to cost me? And when can you do it? And that's a really overgeneralization, but every project is approved on that basis. Typically in our plant, projects that are under a 2-year simple payback will get approved. Because this is an energy project, the criteria for evaluation is graciously stretched to 7 years. So for this particular project, the VFD upgrade, our payback met the normal criteria for evaluation. So even though we're under tight capital constraints, because of the financial attractiveness of the project, we were able to go ahead and get approval.
What about beyond just approval for the budget on it? Like I know, in production areas, production's king, and sometimes, anything that might put quality or throughput at risk, or, even call it into question. I know paint lines can be sensitive. Were there any concerns around that or challenges getting support on that side?
So one of the biggest concerns and one of the biggest opinions, not fact-based, but one of the opinions that's relevant in our plant is that a paint line needs 4 hours to get ready for receiving the first vehicle. We have no objective evidence for that. No one has done any studies. Part of some work that fell out of this VFD project is we started looking at, well, exactly how long does it take the oven to reach temperature? And what we found is we can reduce that startup time from 4 hours to less than 45 minutes. We're using that information to allow us to decide when we can reduce our speeds from production, which is anywhere between 80% to 92%, depending on where the motor is, to 50% of that value. So we can't just at the start of break, for example, a 15-minute break. There's no way we could do the setback and still maintain an environment that our chemists are comfortable with.
Okay, so it was that using that data and tests to show that, like, look, we're going to make these changes, but it's going to be at that temperature before that first car hits the line.
Yeah, I think the key to this whole thing, Jay, is even though the project was titled VFD,
yeah,
we have 2 fallout projects that came almost immediately. The first one was the interlocking door, and the second was startup and shutdown time from examinations. So now, based on the new meters that we have in place, we've been able to shorten the startup and shutdown time frame, data-based, not opinion-based.
Right. So that helps reduce the opposition or any barriers to it.
Exactly.
Having that to show them.
Yeah. The only other barrier that we had was resource allocation. And I'm sure there's a number of individuals on this call that have too much work and not enough pay, or too much work and not enough people to execute the work. Toyota is no different. Our project engineers are extremely busy, and adding a new project to someone's project load is never well received at the start. But once this one got going and we started seeing the benefits from it, it really picked up quickly.
Right. And then once there was that buy-in, what were the next steps? Like, how did you identify the right solutions or technology that had to be brought in? How did you plan that execution?
So a couple of things. First of all, Toyota Japan, TMC, produces a volume of books that are called standards. So there are engineering standards that we have to adhere to. That then translates to our purchasing group that look for vendors that can meet those very specific standards. And that narrows the field down quite small for the project leader. And in general, we usually have somewhere between 2 and 3 people to choose from, not a broad market. We have long relationships at Toyota. Toyota takes a stance that they care about their vendors. If a vendor is struggling, we will support them. We have changed contract terms. We've bent over backwards to try and keep our vendor base happy. But at the end of the day, we're in business to make money like everyone else. And that selection, Jay, gets narrowed down very quickly by the standards that we have in place. So what equipment do we pick? If it's on the standards list, there's no discussion. If it's not on the standards list, there is an approval process that takes somewhere between 2 and 3 months to go through.
Okay. And then in terms of planning the installation role beyond just selecting the equipment, were there any other considerations that had to go into planning it, like, impact to production, like scheduling during production shutdowns or anything like that?
Yeah, so we talked earlier about this RINGI document, this project approval document, and it is created along with a timeline that has to specifically identify what tasks are being done when. A lot of the barriers to the implementation on this project was accessing the plant to provide the infrastructure necessary for data transfer. So installing the VFDs, the facilities group and or the maintenance group in the shops can perform that task, but they are not permitted through the IT department to do anything with wiring. The PLCs that are selected have to be installed by the vendor according to our contracts. So there was a division of labor, and that has to be taken into account in the project planning stage. A number of the barriers are actually IT driven and not technical.
Mm. So just aligning with that. And then how did you go about it? Like I know you mentioned earlier of, some things are being delayed because it can't interrupt any production or things like that. So how did you work around those production requirements or those production schedules?
So the engineering team in the paint shop took a look at the 43 motors that were involved in this project. And they prioritize them in terms of accessibility and in terms of size. In general, the route that the engineers chose to take was the smallest motors first. And we typically did not do work during the week on that. We did everything on weekend, which of course is premium cost. But even with those premium costs, we were able to proceed with the project.
Okay. And we have a question earlier from Sridhar. That is, he's asking what's the status of redundancy of motors in the process? Like was there any option to consider VFD bypass options on the processes?
Okay, so I'll try and keep this one short. It's a very good question. I talked about Toyota standards. One of the standards that we have is an indoctrination called N+1. So if we have a 2-motor system, we will buy 3. If we have a single motor system, we will buy an additional motor, providing that there are at least 3 other in the building of the same size. So no matter where we are in the building, there is a replacement for almost every significant motor in the plant. And that's how we do the redundancy. We don't have 100% redundancy, but we do have N+1.
Okay. All right. And then actually, before I get on with more questions about the installation, we have a question from Kevin in the chat about how you mentioned you have some more metering now, but before when you didn't have the machine level monitoring, how do you identify those top users or where those big energy users are?
Okay. So when we were doing strictly data analysis, we were just using the single meter into the shop. Identifying major equipment consumers really is a case of having a good inventory of the equipment in the facility. So we have single line diagrams and equipment lists for compressed air, steam, water, natural gas, electricity. Any energy consuming piece of equipment, I actually have an inventory for. And over the last 5 years, we've taken that inventory list and make a status spreadsheet for it. So if we have a motor and it is normally in production, it gets a green symbol. If it is, if it doesn't need to run when there's no production, a different symbol is applied to it. If that motor can be turned off during a demand curtailment day, it has a third symbol. So every piece of equipment in our building now, after 5 years, has a 3-set symbol identifying how we can use that equipment under different conditions: production, non-production, and demand curtailment.
Okay. Yeah, so it's just using that inventory, the nameplate data, and getting the estimates there. Max asking to repeat those symbols, and it's a symbol for, I think you said for, is it only production or?
Yeah, so Max, it's you can pick whatever systemic way you want to choose, whether it's a red light, traffic light symbol, green, yellow, red. In Toyota, we have a culture where 0 means good, a triangle means not so good, and an X means bad. So the three symbols that we chose were relating to production. If a piece of equipment is production only, it's green. If it can be reduced in non-production mode, it got a triangle. And if we can actually shut the equipment down during a demand curtailment event, then we put an X. So it's I don't want to say simple, but it's a very visual, quick check that the operators can use to manipulate how they use the equipment within their ability.
Okay. Getting back to the implementation installation of this work, we have a question from Sridhar on that topic that you just mentioned, asking to explain like that. You mentioned the curtailment, the demand side management, load shading. What are some of the key strategies or methods that you have in place for that?
So one of the wonderful things about being an automotive manufacturer is if the peak occurs during normal production hours, our executive don't care what's going on with demand. They're much more interested in producing vehicles. If the peak occurs between shifts or on a shutdown or on a weekend, each shop is responsible for developing a demand curtailment plan. And those plans are reviewed by both myself and the finance group and the technical groups within each shop. And it's a very detailed action plan. So each individual is named on what their responsibility is. And the only time it gets into a non-name specific ownership is if the same position is filled over a number of shifts. But so the demand curtailment takes a look at down to the motor level. So it's not just lighting, it's not just HVAC setbacks. We look at every motor throughout the building and see what can we reduce during a curtailment call.
Okay. Getting back to the paint line project, when you were once you started the implementation of this, were there any surprises or challenges or anything that came up once you started doing that work of installing the VFDs, connecting them, and getting them coordinated?
Yeah. So first, let me clarify. I'm the energy manager. I don't implement the project. There's a project leader assigned to it. So the feedback that I got from the project leader is that from a technical perspective, there were no major issues on implementation. The largest headache that we had was getting IT to shut the correct systems off so we didn't interfere with existing operations when we were making modifications to the IT infrastructure.
Oh, okay. Right. So it was more of that. How did you coordinate between these different departments that all have this role to play in it?
So that's a really simple question to answer. So part of our modus operandi is to have a start of shift meeting. We do calisthenics for somewhere between 10 to 15 minutes before every shift. And at the end of those calisthenics, there is a hot button list of events that are happening within the shop on any given day. And on those days where we were talking about doing an IT infrastructure install, the issue was brought to the attention of all the operators, all the group leaders. So the heightened awareness was generated and people were watching for any issues whatsoever.
Okay. So that helped.
Not a single person responsible. Is a whole team responsible.
Right. Okay. And have you started to see any results from this yet in terms of reductions? Like, is it already delivering some results?
Yeah, so out of the 43 motors, 27 of them are installed and implemented, and we have started now to do the setback on weekends. Again, the plant management, the shop management decided that they didn't want a full install until after shutdown, until after all the equipment was fully installed. So we've been doing our trials on weekends only. And we've seen a reduction in our non-production energy from about 52% to 43%. So 10% drop.
Okay. And is that like, are the results you're seeing so far in line with the expectations or the estimates that you had coming into it?
Yes, and I'm going to qualify that. So yes, if we extrapolate the implementation time and we extrapolate the similar results for the remaining motors that have not yet been installed, we will meet our expected target of 2100.
Mm-hmm. All right. So, what is
So I
know
saw
often
Sid's question about third-party
the peak monitoring?
monitoring and notification services. I think that's a commercial question, my friend. There are easily 15 or 16 service providers that are courting Toyota almost on a regular basis. And because it's such a commercial issue, I wouldn't want to suggest any one of those individuals specifically.
Okay. There's another question from Eloy about what type of harmonics mitigation do you have with all of those VFDs? Or is that an issue that came up?
So thus far, we have 3 electrical engineers that are responsible for harmonics monitoring within the plant. 2 of them are working in the facilities department, and the third one's working for a pilot project. Thus far, we have had no issues raised on harmonics, but I would not be in a position to expand more on that. When they tell me there's no issue with harmonics, I can't explain what they did or how they came to that determination.
Okay. And there's another question about how many metering points and what the EMIS that you're using for energy monitoring is.
So we are currently without an EMIS. We are currently in data collection mode. We are in data representation mode at the shop level in real time. Any energy reporting that we do is manual in nature. So we're extracting data from a database, using a spreadsheet to manipulate reports into a format that our customers desire. So the first question is easy to answer. We do not have an EMS. Yes, we are evaluating 3, but we've not made a selection yet in terms of which way we're going. So until that selection is made, I'm the EMS.
We have another question about from Jason Pasitka about what other energy related KPIs do you have? So you mentioned like there's the non-production energy one as well, but are there other ones in general related to this project?
How are you, Jason? I haven't seen you for a while. So yeah, we have a number of energy KPIs. Most of them are driven by TEMA. That's our North American head office. Toyota North America, Toyota Manufacturing North America, TMNA. We have a 7-year environmental action plan that identifies what our carbon neutrality goals are, which I translate into terms of electricity, natural gas, compressed air, steam, and water reduction targets. So we do have targets for each one of the utilities in terms of consumption. The only other KPIs that we have now on specific utilities, natural gas and compressed air, is a demand reduction, total demand reduction during production and between weekends. So where electricity is being measured on a percentage of peak, those 2 utilities, compressed air and natural gas, are being measured on total consumption. So it's more of a demand reduction strategy rather than a ratio management.
And he was also asking about whether you have, like you mentioned, the net zero or some targets, if your GHG targets are absolute or intensity based.
So we have a couple of issues there, and because we're on a public environment, I have to say that our website clearly defines what our environmental targets are. So we're looking for electricity carbon neutrality by 2030, and we are looking for natural gas carbon neutrality by 2050. I can tell you that our internal targets are a little more stringent than that. And that's as much detail as I can share.
Going back to the results of this project, I know oftentimes with these types of control project optimization projects, there's often like at the beginning, okay, this is what we can do and the savings that we can achieve. But once you get into it and start really using them, sometimes you see more opportunities. So I'm kind of curious if, like, through the implementation, through this rollout, has there been changes to the plan to capture more savings, like between shift savings or anything else that you see coming up?
Oh boy, that's a loaded question. So let's talk about standards first and sustainability. So the first thing that we are doing is establishing operating parameters for this setback. And under those conditions, we will generally set two sets of targets, one for summer, one for winter. We do find that the shoulder seasons are less variable than the two extremes. That is going to be a SOP signed off by several layers of management. And we do audits of our process standards. So once we establish what those operating parameters are going to be, the project is intended to go to 50%, but if we find 43 works, we'll use 43. If we find that 72 works, we'll do 72. But the target is to set the project up at 50, measure results, verify that we're getting what we're expecting to get in terms of the savings. And then from that point forward, we can then introduce new projects where we look at reducing it even more. Okay. But the current plan is to standardize and sustain. So we make sure that we hit target. And once the target's reached, it is incredibly difficult to change those set points. There's a lot of work that has to go into proving that the current set points need to be changed.
Right. And is there any, like you said, there's a lot of work going into figuring that out for this paint line with this project. Yep. Are there plans then to like roll out those findings to the other lines in this facility or to other facilities?
Yeah. So so we have 2 paint lines in our plastics departments and 3 paint lines in the vehicle metal departments. Once we have this figured out on the north paint, it will automatically be Yucatan or transferred to the south plant. And from there, we'll go to west paint, which is in Woodstock. From there, we'll go into the plastics divisions. And that's strictly a case of prioritizing where do we get the biggest bang for the buck. The paint lines in the plastics department are significantly smaller. The consumption's smaller. Savings are smaller. So the larger paint shops are going to be addressed first. Okay. And we have a term called Yucatan for that.
All right. So it is planned to roll out within those. And I know those are the 2 facilities that you work out of. Is there any plan to, like, with this findings, is that reported more broadly to other facilities within?
Yeah, so Toyota has a standardized database that we report our energy conservation projects into. That database is available to all plants worldwide. What I can't tell you, Jay, is if anyone's looking at it. So the culture is supposed to be on a periodic basis, the departments or engineers are to review that database and see if there's anything that someone else is doing that would be applicable to their shop. I think in practice, what ends up happening is with the restricted resources, people don't investigate that database as thoroughly as they might. And the high hitters, the ones that attract most attention from the officers, are the ones that get implemented throughout all plants.
Okay. So some of the priority ones do get that rollout treatment.
Yeah, that's the reality. But you did ask a question. Is there a system? Yes, there is a system.
All right. What I really liked about this project is that, okay, it's a paint line. You're just controlling the VFDs, matching what's actually needed to what's being supplied. But it touches on all these different, like, involves a lot of coordinating between different departments. It's a sensitive thing. Like, paint finish is very sensitive, I know, topic on that. So I find it like a really interesting project from that side of things. Are there any like lessons learned have gone through this project that like key success factors or key lessons coming out of this experience?
I think one of the biggest lessons we learned is when you conduct an energy audit, don't take shortcuts. Understand what the data is telling you. Make sure that what you're investigating can be validated. And if you have the opportunity, like I did, to be able to show real time the impacts of turning the equipment on and off, it's such a valuable tool to gain consensus and buy-in. So even though the project was a VFD driven project, I think the biggest thing we got out of it in terms of lesson learned is how to improve our auditing or energy hunt process.
Right. Of not assuming just because something's there that it's
that it works.
Yeah, that it's doing what it's supposed to be doing.
Exactly.
Okay, that's great. We have a question from Max. I get on that topic of that rollout, and are people looking at that information that's coming out?
Yep.
He's asking if there's been any like looking at AI tools like Microsoft Copilot to help staff in the plants get quick summaries or find those opportunities that might be relevant for them.
So what we're finding, Max, is our younger generation tends to use AI to assist them in addressing engineering problems. What we are finding is that our officers and executives, the ones that are responsible for the bottom line, are providing direction to not use that as a particular tool yet. I think when an AI can be validated more than they currently are, there may be some adoption at Toyota, but right now our executives are dictating AI shall not be used in our operations.
And for any others on the call, if you've had experience, particularly with that, helping to roll out or find that information, please share that in the chat as well. So thanks, Alan, for describing. So I'm curious in terms of, you mentioned this project is continuing and it's the final stage of the installation is coming up with that next shutdown period. But what's next? What are you sort of looking to as like the next step, either within this or in other projects that you're focusing on?
Yeah, so we are looking primarily again at natural gas consumption. So most of our efforts are looking at either alternate burner designs, fuel switching, or consumption reduction. And again, a lot of it that this company is focusing on is on the non-production side. So how do we make sure that at the end of a shift, the equipment is turned off in a timely manner? We are not touching the issue of energy consumption during painting processes, primarily because the chemistry and the standards for that paint chemistry are given to us from Japan. So we don't have a lot of flexibility in that area. We have, however, looked at facilities equipment, boilers, whether they're steam boilers or hot water boilers, and looking at alternative fuels. So we have recently conducted a hydrogen blending effort and successfully. And we can't get anywhere near an economically feasible proposal for that fuel switching under today's conditions. But we now have some practical hard data on its opportunity.
Okay, that's interesting. I see a hand up from Eloy.
I don't know whether this is a stupid question because Toyota is owned by Japanese. So when it comes to BFDs, are you normally dealing BFDs made in Japan, or you use BFDs other manufactured like from ABB?
Okay, so the VFDs that we're using are North American in manufacturer. We are not being specified to use Japanese manufacturers for that particular process equipment.
Right. So you mentioned before you're sort of given the list of specifications or criteria that it has, and like those specifications are coming from the parent company in Japan. But those, as long as a local or North American company can meet those, then they can be a supplier in that?
Yeah, there are some pieces of equipment that Japan insists on being Japanese made. We also have a plant that's at 480 volt, which is not uncommon, but not common.
Okay. All right. If there's any, we're getting towards the end of this, so if anyone else has any questions for Alan, please raise your hand, put it in the chat or in the Q&A. There's a question from Mahai about what other equipment uses VFDs at the Toyota plant, and I know that is a very massive plant. So maybe narrow it down to like what are the main uses of like where those VFDs are good opportunities are really showing up.
Yeah, so the highest number of VFDs in our facility are connected to HVAC equipment. Most of the other motors that we're using, so for chilling lines for the weld shop, for example, they're also on VFDs. If we have, I think chilled water was probably the best example I can give you, but even water distribution throughout the plant is tied in with cooling towers that have VFDs on them. So it's quite a widespread adoption of that technology, but a VFD is not good in every location. A VFD does not correct for an improperly sized motor.
Right. Yeah, and that's a good point. And Max is asking if you have any tips on getting the operators aware of the need to shut down equipment at the end of shifts and helping get them into that habit.
Yeah, so I can give you some practical experience here. I don't know if your organization has standard operating procedures, but we have specific instructions for team members that are assembling parts on the line, group leaders that are looking after groups of team members, line supervisors that are looking at entire lines, and each one of them has an energy set of instructions. So a team member, for example, might be responsible for changing coupling on an air hose if they notice that it's leaking. And if the group leader discovers it, there are steps in the reprimanding process that will encourage future adoption of those SOPs. So yeah, we get their attention by demanding what they do, auditing what they do, and then enforcing behavior that's not compliant.
All right. That sounds good. All right. A couple of things to wrap up. Thank you, Alan, very much for taking the time to join us today and share about this experience. I think it was very insightful into the work that goes into these types of projects. I have a couple of things just to share with the group. One is this, as I mentioned at the beginning, this Fireside Chat is part of our work building this energy management community. So please, feel free to keep the conversation going. If you have more questions for Alan, we can follow up on the discussion forum that's part of the Energy Management Learning Forum platform. If you aren't already part of the community, you can register with the link that Vita is dropping in the chat. So you can sign up through that to get access if you don't already have it. Another announcement is Save on Energy has just released a podcast, the Energy Manager's Playbook. The first 2 episodes just went live this week, and it's where we have interviews with energy managers that are part of this community talking about challenges they faced in their job, how they've overcome them. This is the first season launch of it, so please check it out. It's available on wherever you listen to podcasts, Spotify, Apple Music, etc. So please check that out. There's some really exciting, the first 2 episodes are really exciting. There's going to be more released over the next few weeks and months. And lastly of all, our upcoming event, we have an energy manager discussion group this month virtually on June 25th. So Vita is going to drop the link to that in the chat as well. And the topic for this month's discussion is going to be tariffs, taxes, and transitions. So an informal discussion of how those changes, recent news and politics have changed how you're approaching energy management or moving projects forward. So thanks everyone for joining today, and keep an eye out for our next Fireside Chat.
Awesome. Thanks for hosting, Jay. Had a good day.
Thank you. Thank you, Jen, and thank you, Alan.
Thanks, gentlemen.
Thanks everyone. Take care.